In this video, we are going to discuss the role of knowledge in games. Last time, we introduced rationality and studied that a rational player will not play any dominated strategy. So they eliminate dominated strategy. Extending the idea of elimination of dominated strategies, we will see we can iteratively eliminate dominated strategies under some conditions of knowledge. Before you watch this video, please make sure you are done with video 1 and the quiz as well. Please also post your answer to the quiz on our Microsoft Teams channel so we can make further discussions. Now we have two players, Anne and Bob. Suppose they have an exam tomorrow, but they also have a party tonight. So what they can do is go to party or go to library for study. So if both go party, then that's good. Each players gets 10 outcome, 10 payoff. But if one goes to the library for study, where the other go to party, then the player who study gets the best payoff, 12. Well, the other player gets 0 payoff. So you can notice that this is a version of a prisoner's dilemma situation, right? So you should choose study no matter what your opponent chooses, because the study gives you better payoff as long as these payoffs represent your preferences and you are rational. Now, suppose you don't know your opponent payoff. Okay, so you don't know your opponent payoff. In fact, you don't need to know your opponent payoff when you have a dominant strategy. You are going to choose a dominant strategy if you have any, no matter what your opponent plays and no matter what your opponent payoffs are. So it's easy. Now think about a slightly different situation. Anne likes Bob, so Anne will be very happy if they go party together. It is also okay for Anne if they go to library for study. It gives her 5 payoff. If the actions are mismatched, for instance, Anne chooses study and Bob chooses party, then it gives her 0. Or Anne chooses party and Bob chooses study, then again it gives her 0. So if you are Anne, what are you going to do? Unfortunately, Anne has neither dominant strategy nor dominated strategy. So your best action depends on your opponent's action. Now, suppose Bob is a party person, so party gives Bob 12 of payoff, where study gives him 0 payoff. And also, Anne knows this fact. Still, Anne has no dominant strategy, even if Anne knows Bob's payoff. But Bob has a dominating strategy, so study is eliminated. And Bob will play party. Under what conditions? If Bob is rational. And then now we can see Anne will play party, comparing 10 and 0, right? Under what condition? Of course, Anne is rational. It requires Anne is rational and Bob is rational, and furthermore, Anne knows that Bob is rational. You see that the fact that Bob is rational is different from the fact that Anne knows that Bob is rational. So in other words, even if both players are rational, and if Anne doesn't know that Bob is rational, then Anne may not choose party because she is not sure whether Bob will play party. If Bob is not, that is, study is his dominant strategy, then similarly before, party is dominated Bob, and Bob will play study as long as Bob is rational, and Anne will play study if Anne is rational, Bob is rational, and Anne knows that Bob is rational. So this is the quiz for video 2. So please try to solve this question before you move forward. And again, post your answer to this question on our Microsoft Teams channel, and so we can make a further discussion on it. In game theory, we usually assume common knowledge of a game and common knowledge of rationality. Common knowledge of a game requires that all the players know the game. That means they know the component of games, including the underlying payoffs and their preferences and everything. And that's the knowledge of a game. But common knowledge of a game requires all the players know that all the player knows the game, and all the players knows that, all the player knows that, all the player knows the game, and so on. So infinite iteration of this statement is common knowledge of a game. And similarly, common knowledge of rationality requires all the players are rational, and all the players know that all the players are rational, and all the players know that all the players know that all the players are rational. And again, all these statement goes to infinite. Under the assumption of common knowledge of a game and common knowledge of rationality, players iteratively eliminate their dominated strategies. And such an elimination process may yield some plausible outcome.